Okay, now we're going to look at the position of carbon in the reactivity series of metals. Now, carbon is not a metal, so we cannot react it with oxygen the same way how we react metals with oxygen to see their reactivity. Alright, but we can use a different kind of experiment, which is this activity 4.4. Alright, this experiment is to determine the position of carbon in the reactivity series of metals by heating the following substances. Okay, so this is the concept. Now, if you look at the reactivity series of metals with carbon and hydrogen in it, you will see that carbon is more reactive than zinc. Okay, carbon is more reactive than iron. But carbon is less reactive than aluminium. Carbon is less reactive than magnesium. Now, if you look at what materials we are using in the experiment, zinc oxide with carbon. Okay, let's see. Zinc and carbon. Carbon is more reactive than zinc. So that means carbon can remove oxygen from zinc. So you see, this carbon because it's more reactive than zinc, so it can remove oxygen from zinc. So in normal human terms, we say carbon is stronger than zinc. So carbon can snatch oxygen away. Right? Okay, let's look at the second one. Aluminium oxide with carbon. Okay, so you see, aluminium is stronger than carbon. Aluminium is more reactive than carbon. So can carbon snatch oxygen from aluminium or not? Cannot, because aluminium is stronger. So aluminium will hold tight to the oxygen. Carbon cannot snatch oxygen away from aluminium. So you see, this experiment, carbon is less reactive than aluminium. So carbon cannot remove zinc oxide. Okay, carbon is more reactive than aluminium. So carbon cannot remove oxygen. Carbon is less strong than aluminium. So carbon cannot snatch away the oxygen from aluminium. So for experiment B, there will be no reaction. Now how about C? Lead-2 oxide with carbon. Lead-2 oxide with carbon. Okay, lead is Pb. Lead-2 oxide with carbon. Is carbon more reactive than lead? Yes, carbon is more reactive than lead. So carbon can remove oxygen from lead. In fact, because it's so much more reactive than lead, so the reaction will be very vigorous. So carbon can remove oxygen from lead. See? Carbon, in normal human terms, carbon is stronger than lead. So carbon can snatch oxygen away from lead. So there will be a reaction, and the reaction will be quite vigorous because of the distance, okay, between carbon and lead. Very big difference, carbon and lead. Okay, very much stronger, very much more reactive. So this is the experiment. Put a spatula of carbon powder inside the crucible. Okay, so this carbon here, put into the crucible. Alright, and then put a spatula of zinc oxide powder. So this zinc oxide powder, put a spatula. Okay, mix it together and place the crucible. Okay, this container here is a crucible. Place the crucible on a pipe clay triangle. So in 2D drawing, you only see two circles, but actually it's a triangle that you put onto the tripod. Okay, then heat the mixture. So heat the mixture strongly and observe changes. So like I said, Okay, first one, there will be a reaction because carbon is more reactive than zinc. Second one, there will be no reaction because carbon is less reactive than aluminium. And the third one, it will be quite a vigorous reaction because carbon is much more reactive than lead. So carbon can remove oxygen from lead. So you see the word equation. Zinc oxide plus carbon, it becomes zinc and carbon dioxide because carbon take the oxygen. So carbon, oxygen becomes carbon dioxide. Aluminium oxide and carbon, there is no reaction because carbon is less reactive than aluminium. So there is no reaction, no equation here lah, because there's no reaction. Lead 2 oxide and carbon, so becomes lead only. Okay, lead plus carbon dioxide. Okay, let's name the metal that's less reactive than carbon. Which one is less reactive than carbon? Zinc and lead. Explain. Alright, because there is a reaction and carbon is able to remove oxygen from zinc oxide and from lead 2 oxide. So based on the results of the activity, complete the following sequence according to their increasing reactivity. Okay, increasing reactivity. So this one is the least reactive, followed by the most reactive. So which one is the least reactive? Lead, isn't it? And then followed by zinc, followed by carbon, and followed by aluminium. Okay, give one application of the position of carbon in the reactivity series of metals for industrial use. Explain your answer. So how do you explain this? So metals which are less reactive than carbon can be extracted. Okay, can be extracted by using carbon. So you use carbon and the metal ore and then extract the metal out. Okay, remember when we find minerals in the earth, they are in their ores. Alright, so we need to use carbon to remove the oxygen from those ores so that we get the pure metals. So that's called extraction. We extract the metal out from its ores. Okay, and number 5, if carbon can remove oxygen from a metal oxide, it means carbon is which one? More or less? If it can remove oxygen, it means it is more reactive than the metal. But if carbon cannot remove oxygen, means it is less reactive than the metal.